Now we move on to a system of 3 equations and 3 unknowns, which can be represented as so. The coefficients of our first variable, which we'll call x, are in this column, coefficients of y in this column, coefficients of z in this column, and the number on the other side of the equal sign is in this column. This is an augmented matrix representing a system, and it's really pretty easy to understand that. Just be sure that you do. So at every point, each row represents an equation that can be obtained from the original system of equations by simple row operations that correspond to elementary operations on equations. Okay, so you see the process here. Now I worked this out step by step, but let's just get an overview of the process. Okay, what we want to do is we want to get zeros down below the 2 here. Okay, and there are various ways we can do this, but we want to get, if possible, some number here and then zeros below it. And then we want to get 0 here. Now that happened, we didn't really have to do anything to make that happen. It happened in the process of getting this 0. We just happened to get a 0 here. At this stage, our equations would be a set of upper triangular, well, we'd have an upper triangular form of the system. This means 3y equals 9, so y equals 3. We could substitute that value of y into this equation, which doesn't have any x. It just, it's z equals 3z equals 9, so that z equals 3. We substitute that value for z into this equation, which contains only y and z terms, so that when we substitute for z, we're left with only a y term, and we can solve the equation for y. And now we have a value of y and z to plug in to the equation we have here, which leaves us only the x term, and we can solve for x. And you have already done that, I believe. Okay. Now, we get upper triangular form, and that's great. We refine the upper triangular form a little bit. For example, and I could have done this step and this step all in one, but I wanted to illustrate it real specifically here. If we take 1/3 of the third row of this matrix, we get this, because 1/3 of 3 is 1, 1/3 of 9 is 3. And this simply means then no x, no y, z equals 3. So right there is a specific solution for z. Now, it would be nice, and we're actually going to do it, to get the first 3 columns in this form. Because what does this mean? This means x, no y, no z, equals some number. X equals what? So if we get it into this form, we can just read off our value of x. And this means y equals some number over here. And this means z equals whatever the number is over here, which we know to be 3 at this point. Okay? So we proceed from here to try to get this form. And the first thing we do is we go ahead and we multiply the first row by 1/2, which is going to make this number 1. We multiply the second row by 1/5, so that this number here becomes 1. And of course the rest of the numbers follow along. So 1/2 of 2 is 1, 1/2 of -4 is -2, 1/2 of 5 is 5/2, 1/2 of 9 is 9/2. And we do this with fractions. We don't do decimal approximations. In some very limited cases, maybe sometimes we can, but decimal approximations are only approximations. They're not exact, and they can lead you to a lot of trouble in certain circumstances. Okay, so we don't do decimal approximations, we do fractions. Okay, and the second row times 1/5. 1/5 of 5 is 1, 1/5 of -8 is -8/5, 1/5 of -14 is -14/5. Okay, so what can we do now? Well, we've got a 1 here. if we multiply this row by 8/5 and add to this row, we're not going to affect the 0 or the 1 because we got two zeros here. But we're going to get rid of that negative 8/5 and make that into a 0, which is what we want there. And if we multiply the first row by negative 5/2 and multiply the third row by negative 5/2 and add it to the first row, we're going to get rid of this. And of course, we can multiply this row by 2 and add it to this to get rid of this negative 2. Now, we can't do the negative 5/2 of this row plus this one to get a 0, and then do 2 times this row added to this one, because then we'd have to do 2 times this and add it to the 0 we got here. We'd mess it up. So we have to do it in the right order. And that's done here, at least in the first step. And really I work from left to right. Okay? I add 2 times the second row to the first, which is going to give me the 0 here. And you can do the arithmetic. 2 times negative 8/5 is negative 16/5, okay, which is negative 32/10. And you add that to 5/2, which is 25/10, and you get negative 7/10. Okay, I was looking for it. Okay, and now we've got 1 with zeros below it here. In the second row, our first number is 1. We got a 0 above and below that. And now in the third row, we're going to be able to add multiples of the third row to the second and the first row to get zeros here, and it's not going to interfere with the 1s or 0s that we have over here. So we add, well, what do we have to add to get rid of this? We have to add 7/10 of the third row. So we do 7/10 of the third row added to the first. And then we do, what? 8/5 of the third row added to the second. That's going to get rid of the negative 8/5 here. And we'll end up with what we want here, and the numbers we end up with will be as they are. And I've suggested that you work those numbers out just to practice with the fractions, but I'll tell you that the numbers are just 1, 2, 3. Now, down here I demonstrated the addition of the two fractions in case anybody needs that, because I know that almost all the work done with fractions in secondary and elementary schools is done by punching them on calculators. So people really don't understand fractions as well as they really need to, and here's one place where that starts to cause problems. It also causes problems in simplifying algebraic expressions. But everybody knows we get a common denominator. So to get a common denominator, what do? We want the common denominator between, okay, we want to add 5/2 and negative 16/5. That's going to give us our negative 7/10. So we're doing that calculation. Common denominator between 5/2 and 16/5 is 10. So we got to get a denominator of 10, meaning we have to multiply 5/2 by 5/5. Because the 5 has to multiply 2 to give us 10. And we can't multiply, we change the value of this fraction 5/2 if we multiply it by something other than 1. So we have to multiply it by 1 in the form of 5/5. That'll give us the fraction in with denominator 10. Okay, over here we multiply negative 16/5. Denominator has to be multiplied by 2 to give us a denominator of 10. So we have to multiply this by 2/2. And we do that and we get the common denominator. And what we get is 25/10 minus 32/10, which is negative 7/10. And I didn't do that intermediate step. So make sure you're comfortable with fractions. You're going to have to do a lot of them, and that can only benefit you.